Yep. All right, everyone. Well, welcome to CS410 Advanced Functional Programming. It's really nice to be here in person again. So this is going to be going on for 10 weeks or so, I think.
Yep.
And the team that will be delivering this course is rather big, given the few students we have. So first of all, you have me, so I'm the lecturer, I'm Guillaume Allais. Then you have Frederick Norvald-Forsberg, who's been lecturing this course for the past few years and will be co-lecturing, so heckling and offering useful suggestions. And then for the labs, you have two overqualified demonstrators, so it's really, they're domain experts, basically. They do this as their day job. At the university. So if you have any questions, they should be really, really helpful. So that's Sean and Andre. So there will always be one of the two in the 3 hours of labs that you have to help you. So don't hesitate to ask them questions. The events, so we have a timetable where we'll be meeting for lectures on Mondays and Tuesdays. So Monday today. And then immediately after the first lecture, you'll have a lab. And then on Tuesdays, you start with the labs, and then you'll follow up with a lecture in the afternoon. And finally, on Thursdays, you'll have the last lab, and typically the deadlines for the coursework will be on Thursdays. So this will be your last chance to get some help before the deadline. So for the lectures, we'll give you some 1-minute papers pretty soon. So this is a way just to give you some feedback. It also helps us see...
Should I do this now?
Yeah, sure. It helps us see the attendance numbers and so on. So as I said, Fred will be co-lecturing. This is really nice. And you'll actually see a bit of it today. And then again tomorrow, because I will only be able to attend the first half of the lecture tomorrow. I have to give a remote talk afterwards, so I will just disappear, but you're in good hands with Fred. All of these lectures are recorded using OBS, and then we'll try to upload them as soon as possible on YouTube. I'll post the link to the YouTube channel on my place. And the files for the courses, but also the coursework, will be on GitHub, so you can access them already.
Should we maybe stop a little bit and explain the 1-minute papers?
Oh, sure, yeah.
First of all, we are reusing old 1-minute papers, so ignore the fact that we're in the past, ignore the fact that the title is wrong and so on. Don't ignore your name, don't ignore the 2 boxes. Right? So we'll use your name to take attendance, and we'll use the boxes to try to do better next lecture. Yeah. If you don't have a pen, then find a friend who has a pen. If not, try to stab yourself and use your blood or something like this. Or we can deal with it at the end of the lecture. So the point is that we would like to get some feedback, what we should spend more time on, what you didn't quite understand, and so on. And also, as an added benefit, we will get your names, we know you were here. Ignore everything else on the paper. That's just us trying to reuse the big stacks of things. Yep.
Yeah, so this will be useful to get feedback, but do remember that all of the questions you put in the 1-minute papers can only be answered at the next lecture. So if there's something you don't understand during the lecture, it's probably a good idea to actually ask a question at that time. The papers are helpful to cover it again, but this is not the most efficient solution for you. Yeah, then the labs, as I said, they're domain experts, and you won't get separate exercises to do in the labs. You will actually get the coursework that you will be marked on, and so you can get help from the demonstrators. You can also, of course, talk to each other and try to come up with innovative solutions as a group, but the submitted work should be your own, right? So as a way to check this and make sure you really understand how things are done, For one of the two courseworks you will need to book a meeting with me, and then we can go through your solution, talk about it, discuss what could be done maybe more efficiently, what was really nice, and so on. If you want to talk about the...
No, I think that's about covering it, I think.
Okay.
So we'll release the first coursework end of today, beginning of tomorrow, I think, right?
Yes.
Yeah.
Later this
And
afternoon.
The deadlines for the courseworks, maybe you to tell them about?
I thought they were here. Yeah, okay, they're a bit later. Right, so the courseworks will be from the repository. The way to submit it is to create a private repository, either on GitHub or the departmental GitLab, and to invite me. This way your solutions are not floating around on the internet, but we can also have more of an interactive process to mark the coursework. There are 2 projects this year. So the deadlines are always Thursday, 5 p.m. This way you get a last chance to ask questions at 1 during the last lab of the week. And the first one covers the first few weeks. It's worth 40% of the final mark. And the second one is a bit bigger, so it will be 60%, and it will run after the project submission deadline. The marking scheme for the project is typically that you get 85% to actually answer the questions that are in the module, and then you can get a further 15% by coming up with an extension to the project that is interesting, challenging, elegant. So there's up to 15% marks in there, depending how far you push it. And then I already talked about the in-person meeting. So that's it.
And you probably know this, so you can probably add things up yourself, but you notice that this adds up to 100%. So just to be very clear, it's 100% coursework. There's no exam. Right?
Oh yeah.
So in week 5, you probably have a good idea that you're going to pass the class. I mean, you probably won't have 100%, so you won't have all of the 40, but you will be very close to it. So you can estimate how much time you want to spend on this and on your projects.
We've tried to make them fun, so
Yeah.
it should be fun. Yeah. Right. So as I mentioned, the lectures will be recorded, and we also have some asynchronous methods if you want to ask more questions outside of the 1-minute papers and the labs and everything. So you can send us emails. The email addresses are on my place in the presentation of the course, but of course it's just like first name, dot name at Strath. And we also have a Mattermost channel if you want to ask like questions to a wider audience so that everyone can benefit from the answers. And so I think this is the final one that's the final point that's kind of important. There are plenty of ways to catch up. We'll try to upload the videos fairly quick and so on. So if you're sick, whether it's the flu, COVID or whatever, please don't come in. There's no need to spread it around, right? I think we've covered everything for the admin.
And I think if you're feeling, for some reason you can't come in, if you let us know beforehand, we're very happy to set up a Zoom meeting so you can follow live if you want as well. I mean, it's no big deal, right?
Right. That's a good point.
Okay, is that all the admin?
I think it was, yeah.
Okay, there's some things for you to do as well, yeah.
Yeah, so this week, so you'll get the first coursework a bit by the end of the day. But before that, there's the 0th coursework, which is installing the programming language. It can be a bit tricky in some machines, so you'll get support for that in the labs. Actually, I should have put another bullet point where you compile coursework 00, hello. So it's again from the GitHub repository. So 2024. So there's already something there, and it should allow you to check that the language is properly installed, the standard library too, that you have the right versions. I've tried to make the imports so that it will fail if you have an old version of the standard library or the compiler. And you'll get to run your first Agda program, hopefully by the end of the day or by the end of the week. Then you can connect to Mattermost so that you know where it is. and then start creating the private repo so that we can get things started.
So hopefully you can tick off all of these in the lab that's following this lecture. Right? So that's also a philosophy we try to follow, that you shouldn't have to do, hopefully not any work outside of the lab hours. So we have a lot of lab time so that you can concentrate on your work in the lab when there's demonstrators around that can help you, and then hopefully you can go home and actually relax when you're at home. That's the idea.
Yeah, and one thing I forgot to mention, actually, it's because the coursework is starting from week 1. You obviously won't have seen everything that's in the coursework, but that's perfectly fine. You can just skip the questions you cannot answer yet because you don't have the relevant notions, and then come back to them in the next week or so. But if you've already done, I don't know, 20% of the coursework through the first week, you're on track to do everything by week 5. So you don't need to finish everything on the first week. Right, so we might be able to talk about some.
Are there any questions about the admin
content,
side of things? Something that's not clear? Yeah?
What would the attendance expectation for the labs? Is it kind of you only go if you need help? Or?
Yes, I would say yes. So the labs are there for you, but they're not there for us to check on you. So if you're happy, and maybe you're happy, I mean, you could also get help in the Mattermost channel, for example, right? So if you can't make a lab, then there's no big deal. The lectures we would like you to come to because it's nice not to talk to an empty room. But we can't force you. I mean, we're all adults. Right?
Yeah. Yep. Right, so now we have about 40 minutes to talk a bit about the language. So if I'm going too fast, don't hesitate to stop. Like, we have 20 lectures, so we have time to spend, right? I'm just giving you a broad overview of the language and some of the features, and then we'll come back to specific ones throughout the lectures. So we'll start with some syntax, and then we'll see some fundamental concepts that are new to this language that you haven't seen in Haskell, for instance. And finally, if we're going fast enough, we'll have our first proof of correctness of a program by the end of the day. So let's see. So first of all, Agda is a dependency-typed functional programming. So what does it mean? Programming language, what does it mean? So functional means a lot of things depending on who you're asking. But in this instance, it mostly means that functions are first class. You can create them on the fly, you can pass them around, you can call them, you can store them in data structures, you can do all sorts of partially apply them. Dependency typed, well, it means that it's statically typed. So you will never get a runtime error because you're trying to add a string to a number, for instance. You would get a compile time error telling you to fix the code in the first place. So that's the static part. And then the dependent part, it means that the programming language and the language used at the type level are one and the same, which means in particular that you can actually run arbitrary functions at the type level. So you can have a really powerful type system that allows you to express all sorts of things. Right, and in particular, there's no separation between the terms and the types, which means that values can flow into the types, and so you can actually say something about a value you will only get at runtime. After you perform the check on it, for instance, you can have evidence that the check was successful, which you can then use later on. So that's the main idea, the fact that you have these first-class functions, and then the fact that they are actually available at the type level also. So our first bit of syntax. Yeah.
I have a question, Guillaume.
Okay.
Why are we using Agda? Why are we not using Haskell?
Why? Well, so in Haskell, you don't have this. There are ways to try to create these kind of dependencies, but really clunky, really verbose. You do have two different languages, one for the terms and one for the types. which means you need to learn 2 languages. Here you're only learning 1 and doing all of the work. Did you have something else in mind?
No. I just wanted to.
Yeah.
It's also good to learn another language, I think, right? So you've done Haskell last year, and this gives you a slightly different perspective on what functional programming can be.
Yeah. So another thing that's actually quite important is that Agda was designed with dependent types in mind from the very get-go. And so you have a lot of support to work with them because it was assumed that you were going to work with them. So you have this, you can see that I'm using an Emacs buffer here, and I have some semantic highlighting of just the 1 line of code you've seen so far. But you can also have a rich interactive experience with the compiler. So you're not just writing your program, sending it to the compiler, seeing whether it's okay. You're actually building the program as a dialogue with the compiler. Okay, so the first bit of syntax, yeah, it's already mentioning a lot of different things. So here variable is a keyword, that's why it's in bold in my Emacs buffer. It might be different in yours depending on the semantic highlighting you're picking. And then I'm introducing a bunch of variables that I'm saying are type set. So set is the name of all types in Acta. And then this kind of syntax is very common. So you have a bunch of identifiers, a colon, and then a type. And it's telling the system that you're declaring new top-level constants. In this instance, they are in a variable block, so I don't need to actually define what they're going to mean. I'm just saying they should be considered to be variables of type set. So when I use them without binding them first somewhere in a type, they will automatically be generalized over as sets. So in Haskell, this would just be silent, and then when you write an unbound variable in a type, it would automatically be considered to be a type variable. But in Acta, you have to be declare first on everything. So that for the reader, it's a bit clearer also what's happening in the file. And of course, this is not limited to types. Here in the future, you can have arbitrary expressions as long as they are value types. So you can sort of enforce your naming conventions in the file.
I guess a more boring thing to point out is that all of these lines that start with 2 dashes, these are comment lines, right? Just
Oh, yeah.
to again maybe state the obvious, but so that's why they are kind of orangey.
Mm-hmm.
So they don't mean anything, it's just a comment, doesn't mean anything to the compiler.
Right, so our first function is the identity function. And it will have type A to A. Oh, maybe I shouldn't. No, I shouldn't. And so here I didn't need to mention A because I had declared it in the variable block, so it's automatically generalized as a type. And you can see the first gadget showing up here. So first of all, when I typed it, it was not highlighted. Because this is just me adding new content to the file. And then to get the feedback from the compiler, I need to load the file. So this is done by pressing Ctrl-C, Ctrl-L for loading. In Emacs, if you're using a different editor, it might be a different key binding. And you can see that the identifier got highlighted a certain color. So in my scheme, green means top-level definitions or function definitions. And then I got the type also highlighted. Purple means bound variable, so it was just a bound variable. And then, so I have my type declaration, just like I had the declaration for the variables where I had identifier, colon, and type. So this is a new constant called ID, and its type is AROA. And then I have actually a definition. So this time I repeat the identifier and then I assign it to something. And in this case, I used a question mark. And then when I loaded it, it turned it into this hole that the compiler is showing me. So maybe I can try to split my screen. And if I look at the right file. So if I look inside the goal here, this is done using Control-C, Control-Comma in my setup, but you can find all of the key bindings online. I get this helpful second buffer telling me what the goal is and what's in context. So there's not much in context because I haven't introduced anything yet. There's just a variable that was automatically generalized over, and you can see that it is indeed of typeset. So then I can say that the identity function is the anonymous function that binds its input to X and then returns X. So this is what the syntax is. The lambda is the equivalent of Haskell's backslash. You can also just use backslash if you want. And it's the anonymous function, and then we have an arrow in the core, the body of the function.
How do you type the lambda and the arrow?
Yeah, so Agda has Unicode support, so you can use arbitrary Unicode characters, emojis if you want, although you probably shouldn't. And if you're wondering how to type a character, then you can, in Emacs, in other editors, I'm not sure, place the cursor on it, then press Ctrl-U, Ctrl-X equals. It all becomes muscle memory at some point. And then you get this character information table that tells you a lot of stuff about the character, but the important thing is this toInput line that tells you how to type it. So this is relying on the Agda input method, which means that you need to be in an Agda file for this method to work. So that was for the right arrow, but for the lambda, you can see it's, you also have the input methods, and there are various ones. Some of them have mnemonics, like capital GL is for Greek L, basically, and you can assume that you'll get capital GO, capital GA, etc. for the other letters. Okay, I think that was it. Inspect the goal, refine. So I've included a link to the list of all of the comments that are available. You can play a bit with them. Right, so then because the type and the, although it doesn't really play here. So it's quite common in Agda to have both your programs but also proofs about them. This is one of the major benefits of this programming language. But before you can do full-blown proofs, maybe you want to write some simple unit tests that will allow you to check that you actually implemented something that makes sense. So these unit tests can be defined by just using underscore as the identifier. So underscore in Agda, it can be used in different contexts, but every time it basically means that you don't care. So if you use it as the identifier, it just means a throwaway definition that you're only using for unit testing. So in this instance, I've created this test where I'm saying I have a function from B to C. I have a function that takes a function from B to C and returns a function from B to C. And here I can use the identity function, and this is basically to check that when I said it was a function from A to A, it was actually a polymorphic function from A to A, rather than just something at a specific type. So in this instance, Agda was able to figure out that if it just picks B arrow C as the value for A, then the thing will type check. So it's happy to do it this way. Okay. Do you want to do composition, maybe?
Okay. Can you change the keyboard, please?
Oh.
Okay, so let's see if we can write code for composition. So first of all, so I want to use this symbol for composing two functions. And this declaration says that this is going to be an infix symbol. So what is composition? I want to take one function, another function, and apply one, and then apply the second one, right? So that has two arguments, and it's going to produce a new function. And these two arguments go where the two underscores are in this. So first argument goes in the first underscore, second argument goes in the second underscore. So I do this, and then I want to type this symbol, and I happen to know that that's \O. And then like this. And then I still have to give the type. So what should the type be? Well, I said I wanted something to something to something, right? Two arguments. And I wanted to compose two functions. So if I have one function from A to B, and if I have another function from B to C, then I will get a function from A to C. Right. Does that look about right? So I have this function takes me from A to B, another function takes me from B to C, then overall I can go from A to C. Right. And I've done it in this order. Obviously it doesn't matter if you take this argument first or this argument first, but this is the traditional way to do it. Right. Okay, so I give the type, and then I say, what is F compose G? And I don't quite know what it is yet, so I'll just put an underscore here on the right, and then we'll figure it out step by step. So I load the file. So before, when Guillaume defined the identity function, he just had symbol. Oh, I keep pressing that button. Symbol sequence question mark, and then I said, okay, I am going to introduce a function, so it's going to start with a lambda, right? But just like in Haskell, you can also introduce arguments to the left-hand side here, and we just replace the underscores with where the argument goes. So my first argument I'm going to call F, the second one I'm going to call G, and in this case it's exactly the same as if I wrote lambda F, lambda G goes to something, right? So if I now reload, and I look at the goal, Control-C, Control-Comma, then I see that I have two things around. I have the F and the G, and they have these types that the arguments have up here. And my goal is to produce something of type A to C, right? Okay, so then again, since I'm trying to produce something which is a function, I could take an argument on the left, and I wonder if I need to put in brackets around this. Try without it. Okay, I'll get an error without it. Right, so I have this thing applied to A equals some question mark, and then I reload. Right. So now if I look at the goal, I say I still have to make a C, and I have these three things around now. I have the F, the G, and the A. Right. Okay, and by now I can look at what I have, and I can play some Lego and see what fits. Right. So I say, okay, if I want to make a C, well, I have an F which will make a C for me if I give it a B. So I can say, well, this is F of something. And I can check what the type of this is with Control-C, Control full stop. Except I can't. Control-C. I think your laptop has something bound to Control full stop. We should fix.
Does it?
Okay, so we'll just have to do it in our heads in this case, I think. So I want something of C, F of question mark should have type C. So I can try to give this Control-C, Control space. So that fills in the hole, but I had a question mark in the thing I gave, so I still have to fill in that question mark, right? So I can look at this one. Now we see that my new goal is to make a B. And I have a G which will make a B for me if I only give it an A. So I can do the same game. g of something. And then here, my goal is to make an A, but I already have exactly an A, so I can fill in the A here, right? Okay, and then we see that what are we doing? We are applying G to A, and then we're applying F to G, so that is the composition, right? But you can kind of do it in small steps and just see what you currently need to do, rather than having to give all of this right-hand side in one go, right? Which you would have to do in Haskell. Okay, so there's this fixed cyclic declaration, which means that if I now write F composed G composed H, then because this has been declared as infix right, then this associates to the right. So this, with no brackets, means this. So I think you don't have to worry too much about these fixed cyclic declarations. Just trying to explain what the syntax means. Right? So typically, if you use something from the standard library, we'll have this defined already. So it's just a way of disambiguating what it means to have 3 of these. Right? Could either associate to the right or to the left, and in this case, it's associated to the right. Okay, and then here now we have another one of these unit tests. We're saying I want the function from A to A, and one way to do that is to compose the identity function with itself 3 times, right? So let's comment this in and reload. And I'm not sure what this is about.
Yeah, this is a fixity further down the file.
Ah, okay. So it's something further down the file, but Agda didn't complain about this definition, right? Whereas if I change this to A to B, then we get a type error here. Right? Okay, do you want to take over the long string?
Sure. Right, so far we've only seen top-level definitions where we stated the type at the beginning and then we gave the implementation. And we saw cases where we used ID in a context when we had BROC to BROC, for instance, where the constraint was coming from the outside. And again, we're using ID at a specific type, but the context was telling us which one. Sometimes it's not possible, and so we like to sprinkle some type annotations in inline code. Agda doesn't have a specific construct for it. We can actually implement it as just a normal function. So here I gave it a name, and now let's give it its type. So what does it mean? Okay.
You're in English.
Yes. So what does it mean to have a type annotation? So here, when I'm saying the belongs to, when I'm using the belongs to symbol, I want to have the type first, and then I want to say that the value belongs to that type. So the syntax will go something like this. So first I take a type, set is the name of all types. So I'm saying, okay, I have a value called A of type set. And then to say that the value I take needs to have that type, I can just reuse the A again. And then because it's a function, I need to return something. Well, what do I want the computational behavior of a type annotation to be? I want it to be transparent, basically. I want to be able to constrain the value, but it should compute to the same value again. So I'm going to return a value of type A. And so this strange syntax here, where we have something that looks like a type declaration, is actually a function type, the domain of a function type that actually binds the value that you pass to it. So this is why we are able to mention A afterwards in what we call a telescope. So these nested function types that can bind the value you pass to them.
Maybe it's better if you rename this A to X, say, or something, so it's not
right
from the variable block.
So then I can have this this function, and to define it, I'm going to use case splitting, which will automatically fill in the arguments on the left. So this is used doing Control-C, Control-C. like for case, and then just returning. And it figures out that there are 2 arguments to it, so it automatically fills in the left-hand side. And now I'm saying, okay, what should the behavior of x as type big X be? Well, it should just be the value itself, so that the type annotation doesn't actually influence the computational behavior of the value. Okay. Yeah, so this allows us, for instance, to say I want the identity function at bool instead of saying fully polymorphic one. Okay. So now we will hopefully silence all of these warnings by introducing data structures. So we've seen functions for now, but we can't do much. We can create the identity function, we can compose them, we can create functions like belongs to that throw away one of the arguments, but to actually do any interesting work, we need data structures. So the first thing we're going to use is a record type, if I can stop jumping around. Records are basically structs in C, so you can declare them like this. Okay, so let's go through what it means. So first, I have the keyword record to say that I'm introducing a new one. Then I have a name for it. Again, I can use any name I want. So here I'm using a name with 2 holes for its arguments. That's like a fancy times symbol in Unicode, because I'm going to build the type of pairs. And I'm building the type of polymorphic pairs. So I have 2 parameters, A and B, of type set, corresponding to the type of the first element of the pair and the type of the second element of the pair. And what this is saying is that overall, this will define the type itself. So I can introduce a name for the constructor of the records. So here I'm using comma so that I'm building pairs by just putting 2 things side by side. And then a record is a collection of fields, so you need to also name the fields. You do this by starting a block using the field keywords, and then just giving type declarations corresponding to each one of the fields. So, what? So here I've decided to call the first projection proj1 and the second projection proj2, and of course they're respectively of type A and B. A and B are in scope because they were bound here. So I guess just like for the belongs to type, I could just rename this to really highlight the fact that the names are coming from, they are the most local, the locally bound variables rather than the one in the variable block. Do you have an example of a? No, I don't have an example of a product, so let's make one. So here I want a pair of first, probably the identity function. I mean, it's the only function that you can actually define at that type. And then the second one will be the constant function that takes an argument and then will accept anything but just ignore it and return the value. And rather than writing the code directly, I'm going to interactively build it with Acta. So there are different commands that you can use in goals. They are listed in the manual. You can have a look at them. This one in particular will refine a goal based in a type-directed manner. So here the type is the type of pairs, and the type of pairs as a single constructor, the comma. So there's really no ambiguity on what your next move should be. You should use the constructor for the type of pair. So if you go in the hole and you press Ctrl-C, Ctrl-R for refine, it will actually use the constructor for the pair and then automatically give you 2 goals, one for each of the projections. If I go in the left one, I can look at the goal and see that I indeed need a function from A to A. So I can reuse the identity function. So I write it in the goal, and then Control-C, Control-Space will fill it in. And then for the right-hand side here, I can look at the goal, and I see indeed that I need a function from A to B to A. And I can keep using refine again, because the only way to build a function is to use an anonymous lambda to bind its argument. So this will be done automatically by Agda. Actually, it picked two names. The second one is not so good, but I can just replace it with an underscore. This is, again, underscore can be used in different contexts. Here it's as a binding, at the binding site, and it means that we don't care about the thing that comes in that position. And now I have exactly one variable in scope of type A, and the goal is type A, so I can just put it in. So this is a bit more of an interactive building of programs.
And maybe a boring syntax thing to point out is that there's surprisingly few brackets on this line, right? You would expect it to maybe be some brackets around the whole pair, but the constructor is just called comma, so that's not needed. And you would maybe expect there to be some brackets around the lambda. But again, the lambda binds very strongly, so that's not needed. But personally, I like to put in the brackets to make it look a bit more readable. Maybe you can indulge me this one time.
Yeah, especially for the lambda. So here it only works because it's the last thing. If you add another pair further down, then the lambda binds extremely strongly. So it would actually span over the rest of the line. So it's probably a good idea to actually put in a bracket. But I wrote this interactively, and Agda knows its own syntax, so it insisted on not putting in the brackets because it knew it didn't need them. If you go into the left-hand side here and you hit refine, you see that it will automatically put in the brackets because otherwise the meaning would be wrong.
Yeah, I mean,
So
without the brackets, you don't know if there's comma, it's just the argument here, or if it's like this, right? So that's
oh yeah, if it's part of the body.
Yeah. But basically, you can always put in as many brackets as you want. They don't.
Yes,
So if you're unsure, put in the bracket.
to make it more readable. Yep. And then we have our first pattern matching definition. So we just created a pair, but sometimes we actually want to write functions that consume data. So I can write swap. So swap is the function that takes a pair and returns the same pair, except that the first component is not the second one, and the second one is not the first one. So its very generic type is A times B to B times A. And I can again use the interactive programming to just insert the arguments. There's only one here, so it's not very interesting. And then I can say, well, now I want to proceed by actually inspecting the shape of X so that I get access to the first and the second component, and then I can use them on the right. So I write X in the goal, but instead of giving it as a solution, I had the case-splitting keystrokes, so Control-C, Control-C. And you can see that the left-hand side has been modified to now expose the top-level constructor, the comma, and then give you the first and the second projections that were named automatically using the field names. And now on the right-hand side, I could do a bunch of refines, but maybe I'm going to just tell Agda to fill it in. So just like refine does one step in a type-directed manner, we also have a function, an interaction called auto, bound to Control-C, Control-A, that will try to fill in the goal automatically. The difference with refine is that refine is only doing steps that are forced, but auto will try to put any garbage in. So in cases where there's more than one answer, auto might come up with the wrong one, whereas refine will just refuse to take any steps. But in this case, there's only one possible answer. So instead of writing it myself, I can just ask Agda to complete the content of the body.
Could we maybe rename the variables here as well? It's a bit confusing. So Agda picked these names based on the name of the names of the fields,
Yes.
but they are just variable names. So it would maybe be clearer to rename this to XY or something like this, or AB. Yeah.
Of course, there's no command to rename variables, which is a very useful thing. But right, so in the comments, there's a few more details. So we give definitions by a by a list of directed equations. So we go from the left to the right. On the left, you only have patterns. So patterns can mention constructors because that's stuff you can inspect, and they can have binding sites to say, okay, I want to capture this sub-expression as this named thing. And then on the right-hand side, you have arbitrary expressions where you can call functions, you can do all sorts of things, and you can use all of the variables that were bound on the left. So we already saw this in function composition, but here it's another example where we actually got them from inside the pattern. Yep.
Does the AB on the right not have to be in brackets? Otherwise, it can turn two there, not one.
Yeah, so without brackets, it would be parsed as something really strange. So it's probably the top level function comma applied to something that's not a valid pattern and something else.
But sorry, you asked about on the right-hand side, right? Yeah.
Right, so on the left, there are brackets to say this is really the first argument. On the right, you don't need them. It's the same as the unit tests before.
So here on the right should be something of this type,
Yeah.
right? And comma produces something of this type. And it's clear that you can't really pass it this way because the equal sign says now it's time to produce something. Right?
Mm.
But personally, I find it much clearer to put in the brackets. It's also kind of, it's an insult to have the brackets on the left but not on the right for your aesthetics.
I was wondering how the functional difference to what program.
But it makes no difference. It's just for humans. Because you see the equal sign, and then if you're a parser, you know that whatever comes here must be this thing. And
The
then the
right-hand
brackets are
side,
not needed. Oh, there's one more question. Yeah.
Can you make a constructor that's like in the form of like MK pair and then directly it's A, B?
Right, so you could name it, yeah, something like this. Of course, it breaks.
And my second question would have been like, can you make like two constructors?
No, so each record type has exactly one constructor name.
Yeah,
You can define a function which which is defined to be the constructor, but here on the left you have to match on the constructor. Right?
so in this case, on the left, you don't need params anymore because the constructor is englobing the whole thing. So it's, again, non-ambiguous. You can throw them in if you want, but they're not necessary. And then, yeah, so I use square brackets because parents are not valid like identifier tokens. But
So a lot of these syntax things is, if Agda is happy, then you're happy. And if Agda is not happy, you change it. Right? It's a lot of trial and error rather than learning the syntax rules themselves. But yeah, it's a good question. I think maybe we take any final questions and then we continue tomorrow.
mm-hmm.
Are there any other questions?
Another would be like for this record, is it like a struct in C, like the only one values, no functions or whatever?
Oh no, you can have functions too in it, yeah. So functions are really, they're no different from other types. You can put them anywhere. You can put a natural number or an integer string. But they are just a collection of fields, essentially. So you don't have any choice, right? You have all of these things. We'll see, the next thing is to see actually some sum types, I think. Yeah, there we go. That's a different concept.
Yes, a record is just a way of putting a bunch of types together as one package, right? So you have your name and your employee number and your office number or something, and you want to say, this is one thing I want to consider together.
Mm.
Okay.
What is this set type again? How should I imagine it?
So it's the name of all types. So if something has type set, it means that it itself is a type. So functions from A to B belong to set, for instance, because they're a type. What else are we
So,
saying?
to say that something has type set means that it's a type.
Yeah. Which is a bit confusing.
So here we are saying if x and y are types, then the type of pairs of a's and b's is also a type.
Mm. Yeah, so we talked about functions, but because they are built into the language, but morally, their type is something like this, right? So the domain is a set and the codomain is a set. Therefore, the functions from x to y are also a set. So they're morally a type constructor, but they are built in because we have added dependencies and everything.
Okay, I think it's time we stopped, so you have time to get to the lab.